Alright, so now we're going to simplify expressions that involve multiplication and division. So what I'm going to do before I do anything else is factor every expression that isn't already factored. This 12x cubed term here is just a single term, so I can't do much with that. So I will leave it the way that it is. This term here, though, can be factored because it has common factors. 3 and 6 have a common factor of 3. X squared and x have a common factor of x. Now I find out what goes inside the bracket. So 3x times what gives me 3x squared. Well, 3 times 1 gives me 3. And x times what gives me x squared? Well, that would be x. 3x times what gives me positive 6x? Well, that should be plus 2. Next fraction. So my 5 I can't do anything else with. This term up here, these two terms up here have a common factor of 4. And this has x cubed and that's x squared, so my common factor would be 4x squared. 4 times what gives me 4? Well, 1. X squared times what gives me x cubed? X. Alright, now for the next term, 4x squared times what gives me 8x squared? So that should be 2. And now, I just have a bunch of terms all multiplied together. So this is one term, 12x cubed. That's another term, 3x. So I can look at the numerator and the denominator and see if I can cancel off anything that's in common. So the first thing that I notice right off the bat is that I've got an x plus 2 bracket in the denominator here, and it's up here in the numerator. So these can cancel each other off. And then I will compare my 12 with my 3. Those are both divisible by 3. So dividing by 3 would give me 4 and then 1. I've got an x cubed term right here and a single x down here, so this x can cancel off with one of these, leaving me with x squared. I look at anything else. I've got a 4. 4 can't cancel with the 5. Neither can this 4. I don't have any more x terms, so it looks like this is about all I can do. So what's left over in the expression now? Well, I've got 4x squared right here. Down here, everything is gone, so that leaves me with just 1 down there. Over here, that's gone, leaving me with this term here, so 4x squared over 5. And now, to find my final answer, I multiply my numerators together. 4x squared times 4x squared is 16x to the 4. 1 times 5 is 5. Now, to get full marks for this question, you'll also need to find your non-permissible values. So your non-permissible values always come from where your denominators could potentially be equal to 0. So if I look at the second fraction first, this denominator here is just the number 5. Since there's no variable here, this will never equal 0. So I don't get any non-permissible values from this expression here. When I look at this one over here, well, I've got this term, these two terms here, which factor to this here. Now if I look at 3x times x plus 2, I need to find out where that could potentially be equal to 0. So those terms cannot equal 0. Well, these are two numbers multiplied together, so they would equal 0 when either one of the terms are equal to 0 or both. So the first solution comes from when this first bracket here, 3x, cannot be 0. To solve this for x now, I would just divide both sides by 3, and that tells me that x cannot equal 0. That's my first non-permissible. For the second one, the second non-permissible is going to come from this one, when x plus 2 cannot be 0. So to solve this, I would just need to get rid of the plus 2 by subtracting 2 from both sides, and that would give me x cannot equal a negative 2. Okay, so that's how you find non-permissibles of that expression right there. Alright, so that's multiplication. Now let's do a couple of division examples. Here's the first one. First one is when I have x cubed plus x squared over 16 divided by x squared plus x over 20x plus 10. So when I have division, the first thing that I do, before I even factor actually, is I always multiply by the reciprocal. Because in order to divide fractions, we always multiply by the reciprocal. So change it to multiplication and then flip that second fraction. Once I have that done, then I'm going to look at factoring everything. You could technically factor before you do the flipping. It wouldn't really matter. So let's look at factoring this numerator. Common factor here should be x squared. X squared times what gives me x cubed? Should be x. X squared times what gives me a positive x squared? Should be plus 1. 16 I can't do anything with. So times, common factor here would be 10. Take out the 10. 10 times what gives me 20x? So that should be 2x. 10 times what gives me negative 10? Should be negative 1. Look at the denominator here. Common factor would be x. X times what gives me x squared? That would be x. X times what gives me x? That should be plus 1. Alright, so now I'm going to look and see if I can do any kind of canceling at all. Well, I start here, and I see x squared. The x squared can reduce down here with this x. So I can say that this x cancels off, and this leaves me with just one x up here. I look at this x plus 1 bracket. I have an x plus 1 bracket down here, so they can cancel off. I have a 16 right here, so I look for something to reduce it with in the numerators. 16 can reduce with 10. Remember, I can't reduce it with this 2 because this 2x has this minus 1 stuck onto it. I can only do anything with this bracket if I have a 2x minus 1 down here, which I don't. So this 2x minus 1 is going to hang around. But the 10 and the 16 can reduce because they're both divisible by 2, giving me 5 and 8. And I think that looks like about it, so let's see what's left over. Right here, the x plus 1's gone, the x squared has turned to an x, so we've got x. Down here, the 16's turned to an 8, so x over 8 times, my 10 is now a 5. The 2x minus 1 is still here. Over, down here, everything is gone, so I've got 1. Okay? So now that all of that is done, I just need to get my final answer. And to get my final answer here, all I would need to do is multiply everything together. So x times 5 times 2x minus 1 can just be written as 5x times 2x minus 1. And 8 times 1 is just 8. So my final answer is right there. And then we have to look at getting our non-permissible values from this thing. So to look at the non-permissible values, you always need to consider when your denominators are equal to 0. So for the first fraction here, my denominator is 16. Well, that's never going to be equal to 0 because 16 doesn't have an x term here. There's no variable. I look at the other one. Well, 20x minus 10. Well, that could equal 0, so my first non-permissible is going to come from right here. Now, to find out what that gives me, I would just have to get rid of the minus 10 first by adding 10 to both sides. So that gives me 20x is equal to 10. To solve for x now, I would just get rid of this 20 by dividing both sides by 20, leaving me with a 1 over 2. So that's the first non-permissible value. However, you might notice that since this is a division expression, I really ended up multiplying by the reciprocal. So if I consider the non-permissibles here, then this denominator right here, which was the numerator of the original, also gives me another non-permissible. So anytime you're dealing with a division of rational expressions, when you find your non-permissible values, you need to look at both denominators, and you also need to look at the second numerator. And the reason for that is because when you flip it, it ends up being the denominator. So in this case, this thing here, x squared plus x, gives you another non-permissible value. Of course, we already factored that, so it turns into x times x plus 1. So my first non-permissible value comes here when x cannot equal 0. And the other one comes from when x plus 1 cannot equal 0. So subtract 1 from both sides, so x cannot equal negative 1, x cannot equal 0, and x cannot equal 1/2. So 3 non-permissible values for that one right there. Alright, so let's look at one more. This one will also be division, but we'll have something else involved into it. So let's get right into it. So this one is 4x squared minus 1 over x plus 2 divided by 4, x squared plus 2x over 8x squared minus 32. Alright, so the first thing that I'm going to do is change this to multiplying by the reciprocal. So I will keep the first fraction the same for now. Multiply by the reciprocal, so I flip that fraction right there. And now I'm going to factor everything. So when I factor 4x squared minus 1, well, there's no common factor here, but what you hopefully should notice is that 4x squared is a perfect square, 1 is a perfect square, and they are being subtracted. So this is a difference of squares. So to factor a difference of squares, I draw my two brackets. What gets squared to give me 4x squared? Well, 2 gets squared to give me 4, and x gets squared to give me x squared. So I can say that, I'll just write it down here, 4x squared is really 2x being squared, right? So in the left-hand position of these brackets, I'm going to write 2x. Up here, this is 1. And what's being squared to give me 1? Well, that's 1, because 1 times 1 is 1. So that goes in the right-hand position, 1 and 1. To factor a difference of squares, one of the brackets gets a plus sign, the other one gets a minus sign. So 4x squared minus 1 factors to 2x plus 1 times 2x minus 1. My denominator here, there's no common factor here. There's nothing else really I can do with x plus 2. Alright, this one here, I've got a common factor of 8 with the 8 and the 32. So I will write 8. And what goes inside the brackets? Well, 8 times what gives me 8x squared? X squared. 8 times what gives me a negative 32, a minus 4. hopefully at this point what you're saying is, hey, we just did a difference of squares over here. This one also looks like a difference of squares because here x is being squared, and then to give me 4, that means 2 is being squared. So what I can do is I can say, all right, well, x squared minus 4 factors using its difference of squares. X is being squared, so that goes right there. 2 is being squared, that goes right there. One gives me a plus and the other gives me a minus. So when I have this here, that can factor further into that. So keep an eye out for that. Sometimes when you factor out the greatest common factor, a difference of squares makes itself visible. So in this case, I will get rid of that and write in x plus 2, x minus 2. Okay? Denominator here has a common factor of 2x. So 2x. 2x times what gives you 4x squared? That's 2x. 2x times what gives you a positive 2x? That's plus 1. Okay. So can we cancel anything off here? It looks like we will be able to, because I have a 2x plus 1 right here and a 2x minus 1 right there. So they can cancel each other off. Just like that. I've got a 2x minus 1 left over, but I don't have any 2x minus 1s in the denominators. I've got an 8. Well, that can reduce with 2, because 8 and 2 are both divisible by 2. So that would leave 1 down here and 4 up here in the numerator. Furthermore, I've got an x plus 2 right here and an x plus 2 right here. So that would cancel those out. So it looks like what's left over now would just be, in my numerator, I've got 4, 2x minus 1, x minus 2. So 4, 2x minus 1, x minus 2, over 1 times x is just x. So there's my final answer for that one. And now we must look at our non-permissible values for the expression. So to find the non-permissible values, the first denominator here, it's x plus 2. So x plus 2 cannot equal 0. I can find out the non-permissible here just by subtracting 2 from both sides to give me x cannot equal negative 2. Next denominator is right here. It's 8x squared times negative 32. Remember, we factored that out, and it was 8x plus 2, x minus 2. So find non-permissibles from here. Well, 8 is never equal to 0, so this one doesn't give me any. X plus 2, well, I already had x plus 2 over here, so this is just going to give me a repetition of this one. And an x minus 2. Okay, so that's a new one. So I've got x minus 2 cannot equal 0. So add 2 to both sides. That gives me x cannot equal a positive 2. Okay, that's another non-permissible value. And now, remember, since it's division, which ends up flipping the second fraction, I need to look at the numerator of the second fraction as well. And remember, that one factored to 2x times 2x plus 1. So this one cannot equal 0 as well. So my first non-permissible from here is going to be when 2x cannot equal 0. So just divide both of those by 2, so x cannot equal 0. And the next one is from when 2x plus 1 cannot equal 0. So subtract 1, so 2x cannot equal negative 1. Divide both sides by 2. That tells me that x cannot equal negative 1 over 2. So here we've got 4 non-permissible values. And that is the final answer.